So, the next series of video we are going to discuss about design patterns. This is important concept and important topic that needs to be learned at the early stages of software development field. There are many reasons for that. We will try to cover each design pattern in a detailed manner in the next series of videos. So first, we will try to relate this design pattern with the real-time example. So many people used to tell that the best time to have lunch is between 1 p.m. to 2 p.m. and the best time to have dinner is 7 p.m. to 8 p.m. so that we can have a good dinner. So similarly, software experienced people usually says that we need to follow these design patterns to make a software reliable and to make a software to make a program in a performance way. So we need to follow these design patterns to make our software best one. So that's our motto. That's our motto behind this design patterns. So the definition for design pattern is they represent the best practices followed by experienced software developers. So software field is in movement from the last 20 years. So from that time, people used to see the many use cases. They used to solve those real world problems using some solution. So that software experienced people trying to group those solutions into a single to a templates. So templates means in this case design pattern. So if there is some common solution for n number of problems, means they will try to treat it as a design. So we need to follow that design if our use case falls in that category. So that's the power of this design pattern. If we learn this design pattern, then we can easily relate any real world problem with the existing design pattern. If there is no if your use case doesn't match with the existing design pattern, then we can create our own design pattern and we can publish our design pattern to the external world. So that's the power of this software design. That's the power of this design patterns. So this is targeted to solve the problems of object creation and integration. So if you consider a software object-oriented programming, then the first thing that comes into mind is object creation. So if there is an object, means there are many things that are related to this object. So object creation, initialization, object communication, like that. So everything will be handled in this design patterns. We will try to cover all the design patterns using some real world example and using some programs in the upcoming videos. Please try to watch all the videos in this playlist. And the design patterns act as templates for the real world problems. So I have already explained about this in the previous context. So if there are n number of solutions, if there are n number of use cases, if n number of use cases can be solved by a single problem, means then that is the template, that is the design pattern. So we can use that design pattern to solve our real world use cases also. So we need to first relate our use case with the existing design patterns use cases. If we can relate that our use case with the existing design pattern related use cases, then our problem is solved. So this was discovered by the 4 people, Erich, Richard, Ralph and John, and they published a book called Design Patterns, Elements of Reusable Object-Oriented Software in 1994. So this book covers 2 things. The first part covers pros and cons of object-oriented programming, and the second part covers 23 design patterns. So actually, the first part was covered by many books, but the second part is a unique one. At that time, these 4 people stands out from the other people. So the reason behind that is the second part, 23 design patterns. So these 23 design patterns falls under these 3 categories: creational design pattern, structural design pattern, and behavioral design pattern. So under creational design pattern, it covers object creation and initialization. For example, in case of software object-oriented programming, we need to create some objects for our real-world use case. So object creation, and then we need to communicate with the object from other objects. So that would be handled in using creation design pattern. And then comes the structural design pattern. Structural design pattern is we have some interface like USB interface, and we have the implementations for USB. So we need to decouple. We need to loosely couple this interface and implementation. If your software or modules are loosely coupled, means then your software is more reliable and more outstanding from other things. And then third one is behavioral design pattern. So if suppose this is a class and using this for this class we have created 5 objects, means if suppose these 5 objects needs to communicate with the class thing, so the communication between class and object would be handled in the behavioral design pattern. So we will try to cover every design pattern in the upcoming video. Discuss about model view controller. So this is the important topic for the next series of videos. Gang of 4, I've invented the software design patterns, 2D3 software design patterns. They use this model, this as base for those 23 design patterns. So you can imagine the importance of this concept. So this is a theoretical one. So please try to watch this video fully, because I will try to relate these theoretical concept with real-time examples so that it won't be very boring. So model view controller. So what is the main aim of model view controller is decouple the things. So consider a train. So for each train there will be n number of compartments. So one compartment is linked with another compartment with some iron rings. If there is any problem in a compartment, then we can easily decouple that compartment and we can put a new compartment. We can attach a new compartment to the existing compartments. So that's the power of decoupling. So here the compartments are individual units. So each individual unit is linked to another individual unit using some coupling factor. If all the compartments are bundled together, means then we can't decouple them. So similarly, in our program we should write our classes in such a way that we can easily decouple the classes. If we write like that, then the code would be reused in n number of times and we can easily manage the code. That's the core concept of model view controller. Here there are 3 things applying for making this theoretical approach to be practical. The first is model, second view, and controller. First we'll discuss about the view. If you're trying to open a college portal and you're trying to give some roll number. If you give some roll number, then you will see the details of that corresponding roll number. The data that you are viewing is the presentation layer or view layer. So that view layer may be different from each application to another application. If you are using Google Analytics, means you would see pie chart, bar chart like that. If you are using some online site, means you would see some filters and some products like that. The things that we are seeing is the presentation layer. It depends. Every application has its own presentation layer. So screen presentation. For example, pie chart, bar chart, and etc. And then next comes the controller. If you're trying to give some roll number, here the roll number would be sent from the client to the server. That would be managed by the controller. So it acts as a mediator between the model and view. Okay. So here view is a presentation layer where we are giving a roll number. That would be sent to the model via controller. We will discuss about the model in the later part of this video. And then it defines the way the user interface reacts to the user. For example, if you are using Paint application, if you have observed it clearly, then you will see that if you are based on a mouse actions, the actual drawing would differ. Here, the user actions are captured by the controller, and based on user actions, it's doing some operations. That's the second point. Defines the way the user interface reacts to the user. So this is done by the controller. So next one comes to model. So model is the holder of the data. For example, if you consider student data, means the student details like roll number, names, and marks, grades, all would be encapsulated and stored in a single object. That would be managed by the model. So, and it also manipulates it. For example, suppose if I'm trying to change the phone number means, I will try to give that request via the view layer. That view layer captures the data and the data would be sent to the model via controller. So the controller is the player who acts as a mediator between view and model. And then model gets that request and it will try to update the existing phone number with a new phone number. So that's the first one, holds data and manipulates it. Example, student object holds name, marks and etc. So this is the basic main concept for the next series of videos about creation design patterns in a brief manner. In the next series of videos, we will try to cover each design pattern which falls under creational design patterns in a detailed manner using real-time examples, real-life examples and also using some practical implementation. So please try to subscribe my channel and try to watch all the videos in the upcoming days. So first statement is deals with object creation mechanism. So if you are writing any program using object-oriented programming language, then you must create some objects. At some cases, the object creation will be very easier. At some cases, it will be a tedious process. So it depends on the use case. If you're creating a complex object means, you should follow some mechanism in such a way that it could be reused for other purposes and it can also be managed well. So that would be categorized, that would be handled by these creational design patterns. There are 6 creational design patterns which solves each use case. So if a use case falls under a particular bucket, then you need to pick the best design pattern among these 6 design patterns. So we will try to discuss about these 6 design patterns in a brief manner. In the upcoming video, we will try to explore the design patterns in a detailed manner using real-time and real-life and implementation. So create objects based on use cases. So here there are 6 design patterns. For example, abstract factory. We should use abstract factory design pattern only if it falls under this category. Suppose if there are n number of families. For example, animal family. Under animal family there are many classes like dog, cat, like that, and we have another family called insect family. We have some classes like ant, like that, and human family. So based on input, we need to, this abstract factory will try to return the best object based on the input. So if suppose your use case falls under this category, then you need to use abstract factory design pattern. So we'll try to cover each design factor in the upcoming video. So for now, just treat it as a brief introduction like that. And then comes to builder design pattern. So builder design pattern means we'll try to create an object from the base or from the scratch. Factory design pattern, it will try to create an object. Using several derived classes. It will try to pick the best derived class and it will try to return the object for that class based on the user input. And then object pool. The main principle of object pool design pattern is to recycle the objects that are already created. And then prototype. Prototype means copy or clone the objects. Singleton. Singleton means only one object creation for the entire JVM process. Life cycle, sorry. So these are the 6 design patterns. If suppose your use cases falls under this category, then you need to pick the best design pattern among these 6. Reduce the complexity of object creation. So actually object creation is a tedious process, and then managing the objects is also a tedious process. So everything would be managed by this creation design patterns if we follow a proper structure, and it will also reduce the complexity and then define the best possible way to reuse the object. So we have created an object by using n number of resources like time, memory and etc. We need to reuse it. If we follow these categories, if we follow these patterns, then we will try to reuse the objects already that I've already created, so that our code would be in a very efficient manner, so that we can save various resources and we can serve n number of clients in a particular amount of time. So please try to watch the next series of videos so that you get the complete detail about the software design patterns. We are going to discuss about singleton design pattern in a theoretical manner. In the next video, we will discuss about the singleton design pattern using some program. So this video is all about theoretical and real world examples. Next video is all about the program. So first, what is singleton pattern? So the name itself suggests that there is something, there is a single, only one thing. That's a singleton means there is something that is which stands alone for one time. So here singleton means only one object. So only one object creation is one allow. If suppose if you are trying to create multiple objects for that class, JVM doesn't allow that. JVM allows only one object creation. That object would be reused by n number of times. That's the power of singleton. So you just imagine a scenario. If suppose if you are trying to create an object n number of times means, for example, consider that n equal to 5. So this is in memory. If you want to create 5 objects means first object, second object, third, fourth and fifth. So 5 objects consume some considerable amount of memory that can be avoided using singleton. But there are some rules. There are some rules when we should use singleton and when we shouldn't use singleton pattern. The first rule is, if suppose some objects has its own properties or own things means we shouldn't use singleton pattern. For example, consider this case: student Lenny equal to new student 1, 100. 1 is the roll number and 100 is the marks. Student Chenchu equal to new student 2, 100. Here Chenchu is the object, 2 is the roll number and 100 is the marks. Here 1, 100 is the specific properties or the specific properties for Lenin object. 2, 100 are the specific properties for the Chenchu object. So we shouldn't use singleton for these use cases, because if suppose if the object has its own or specific properties, then we shouldn't use singleton property. If object has its common properties, if suppose an object doesn't have any specific properties means, then we can use a singleton pattern. For example, we will try to cover that example in using real world examples in the later part of this video. So we will try to cover advantages of a singleton design pattern. Since since JVM is allowing only one time object creation, then it is trying to save the memory. So in the previous part of the video, we would have discussed that if suppose if you want to create 5 objects means, then it consumes 5 object memory. But JVM allows only one object for singleton, so only one object. So the remaining 4 object memory can be reused, can be used for other purposes. So it saves memory. The second point is performance improvement. So performance improvement in this sense, for creating object, it needs some amount of CPU. The object consumes that memory and performance improvement. So these are the two major advantages and main advantages of using singleton design pattern. And then we will try to cover this implementation details in a detailed manner in the upcoming videos. For now, just consider that if you want to implement singleton pattern means, then the class constructor should be private. So we would have discussed about the public constructors in the previous videos, but to implement singleton pattern, the class constructors, all the constructors should be private. So that's important point. Now we will try to cover this part in a detailed manner using programs in the upcoming video. Please try to take a brief thing from this part, and then real world examples. So many have asked me regarding the Java course. So they ask me, why can't you teach me Java course? So I said that I have already spent a lot of time and effort for making a course, Java course. I hosted the Java course videos on YouTube. So please try to go and watch that video. So here, that JVM is the environment. I am the object. So many people are trying to ask the JVM to create new object. But JVM is saying that already one object is created that can be reused. So please try to reuse that like that. So I am the object. So only one object is created. That one object is reused many times. So I am the source for the object. So I am my object. I am is my only one time object creation, so only one time I'm going to post the video. That video is watched by n times. So n times is the n number of times, n use cases where that object help is needed. So here the object don't have the specific properties, so it has a common property, so it can be used by any number of times. That's the real time use case of singleton. And then Java has many singleton implementations. One of the important implementations is runtime class. So runtime class is the singleton design pattern implemented class. So only one object is created for the JVM. So you can use n number of times. So if suppose if you are trying to ask to create a new object, means it will try to give the already created object. So this is the real-time use case where Java is using singleton design pattern. So thanks for watching this video. Please try to watch the next video also, because in the next video we will try to cover, we have covered the practical implementation of singleton design. Now we are going to discuss about factory design pattern. So this falls under creational design pattern. That is, in beginning it is the motto of creational design pattern is to create object and also to initialize the objects. The same motto is for also, the same motto falls for the factory design pattern also. Factory design pattern also tries to create an object and also it initializes the object. So here the definition for factory design pattern is create object without exposing the creation logic to the client. So if suppose I am the customer or consumer, if I'm trying to buy any soap from this shop, so I'm trying to approach the shopkeeper. I'm trying to ask, I need a mom soap, I need Rexona soap, I need Lux soap. The shopkeeper analyzes the request. So and the shopkeeper decides which soap needs to be returned. So that's the factory. Here the shopkeeper is the factory. So we will try to relate the next example with the factory class. So phone manufacturer. If suppose I am the phone manufacturer, I need OS for various phones. I don't have any knowledge about the OS, but I need OS for iPhone. So I'm just asking the OS factory that I need OS for iPhone. So OS factory analyzes that the OS for iPhone would be iOS. The OS factory returns iOS to the phone manufacturer. Now the next time the phone manufacturer is approaching the OS factory and the phone manufacturer is asking I need OS for Samsung phone. The OS factory now analyzes, since the request is Samsung, it will return the Android OS. Okay. And then the next time the phone manufacturer is approaching the OS factory and then he is asking I need OS for Nokia phone. Now the OS factory is written in the Windows OS. So according to this example, the phone manufacturer doesn't have any knowledge about the OS. So the information that the object creation is hidden for phone manufacturer. For him, he needs just an OS for that phone. So that request will be handled by the OS factory. So this is the factory. So here the object creation is done using the input. Input is iPhone, Samsung, Sony. So based on the input, the best object would be returned. This is another example. And another example is, if you are working in a software company, then you would have noticed this kind of scenarios. For example, there are a number of clients, bank client and some small shop client. If suppose a bank client is coming to the manager and is asking some UI developer, best UI developer for some contract purposes. So manager analyzes the resources means UI developers. So he is trying to analyze the UI developers and he will try to pick the best one out, best from among these UI developers for the contract job. After some time, a small shop owner approaches the manager and he is asking that I need some UI developer, but I will pay only less amount of money. So manager analyzes that request. So that here the criteria is less money and UI developer. So he uses those two criteria for picking the UI developer. So according to these examples, the client doesn't have any knowledge regarding the UI developers. He needs just UI developer based on some criteria. That manager handles those criteria and returns the best object for those criteria. So here manager acts as a factory class. So this is another example for explaining the factory design pattern. In the upcoming videos, in the next video, we will discuss about how to write a program using factory design pattern. Now we are going to discuss about abstract factory design pattern theoretically, and also using some real-time examples, and also using some code snippet. In the next video, we will try to explain this abstract factory design pattern using some program, using Java language. So please try to watch that video also for better understanding. So here, first, what is abstract? Abstract means hiding. So for example, consider a real-time case. If you want the fan to work, what will you do means you will try to put the fan switch. Here you don't know what's the technical things that is happening behind the fans working, but you are getting the actual output. You need the fan to work, that's it. The technical inner details are hidden from the actual client or customer. So that's the meaning of abstract. And what's a factory? Factory means it's like a provider. For example, if you have some problem, medical problem. For example, if you have fever, means what you do means you will try to go to the nearest medical shop and you will try to tell your problems. So like, I have some fever and cold, so I need some best medicine. That medical shop owner or medical shop member or representative will try to analyze the problem, and he will try to, or he or she will try to return the best medicine possible. Here, that medical shop representative is the actual factory. The factory provides the object based on. So here types of fever, cold, like that. So this is the meaning of abstract and this is the meaning of factory. So what is the abstract factory meaning? So here abstract factory means super factory which creates other factories. So we have already covered about the factory design pattern in the previous video. Suppose if you haven't watched that video, please try to watch that video and then come to this video for better understanding. So what super factory? So for example, consider another example. Here consider I am the soap manufacturer company. I need to manufacture some soap. So what I will try to do is I will try to divide my company into n number of companies, n number of factories to be exact. So one company tries to manufacture wrappers, the soap wrappers, and the another company tries to manufacture the soap raw materials, and the another company tries to manufacture the other raw materials. The fourth company will try to combine all the raw materials and try to produce a soap. So here actually there are 4 factories which are working under one single factory. So that's one single factory is called super factory or abstract factory, that will try to manage or it will try to pick the requirements from the clients or customers and will try to return the appropriate factories. So the super factory will try to get the output from all the factories and it will try to make it as a final product and will try to release like that. So that's the gist of the abstract factory design. We will try to explain that using this real-time example and also using some code snippet. So this is a real-time example. So I have classified animals into 2 types, domestic and wild. Under domestic category, cat and dog belongs to the domestic category. Lion and tiger belongs to the wild category, wild animal category. So actually, technically, animal is an interface. So it has a method called public int get number of friends. The actual implementation for that method would be present in the lion concrete class, tiger concrete class, cat concrete class, and dog concrete class. These classes would return the actual number of legs. For example, cat, dog, lion, tiger, all of those have 4 legs, so it will try to return the 4 legs. If suppose if some animals have 6 or 8 legs, means it will try to return the number of legs. So this is the actual example. So these classes would be managed by the domestic animal factory. For example, if a customer is going to a shop, if a customer is going to the medical shop and is trying to sell his problems that I have some cold and I have fever, but medical shop representative would return some appropriate medicine. Similarly, client or customer is going to a domestic animal factory and is trying to get some domestic animals. So the client is telling that I need an animal of 4 legs of weight 25 kg. So you will try to return the dog object because that would be the more appropriate when compared to cat. Similarly, for a wild animal factory, based on the requirements, it will try to return the appropriate object. So the requirements are 4 legs and 50 kg. The appropriate object would be lion or tiger. It depends. These two factories will be managed by the animal factory. So animal factory is the abstract for these to the outside world. To the outside world, it doesn't know whether there's an animal factory, wild animal factory or domestic animal factory. It's very abstract. So the requirements for this animal factory would be, I need a wild animal, first requirement, and then the the number of legs should be 4, and the weight of that animal should be less than 100 kg. Based on these 3 requirements, this animal factory would process those requirements and will try to choose the appropriate abstract factory, appropriate factory. So here the wild animal factory would be the more appropriate factory, and it will try to wild animal factory try to return the appropriate object for the criteria. The appropriate object would be lion, like that. So this is the abstract thing. So similarly, if you can say another real-time example, this is the medical representative. So if I am the customer, I am the person who is going to the medical shop and I am trying to ask that I need a medicine for cold, fever, age is 25, like that. Based on this requirements, it will try to choose the according factory, whether light fever factory or heavy fever factory. Using the light fever factory based on other requirements, it will try to return the appropriate medicine. So we can relate n number of examples using abstract factory design. The actually abstract factory design is implemented in Java libraries. So if you are trying to read some XML files using DOM parser, then you would have used the abstract factory, because document builder factory is an abstract factory. Using this factory, you can get the actual factory object. Here, the actual factory object is docfact by calling get instance method. Using that actual factory object, you can get the concrete objects. Here, using new document builder, I am getting the concrete object for this docfact object. So using the concrete object, we can do n number of operations. So this is the real-time example. This is the code snippet where abstract design pattern was implemented in Java library. Please try to watch the next video also, because in the next video we'll try to explain how we can implement the abstract factory design using a simple case from Let's Make Learning Simple channel. Now we are going to discuss about prototype design pattern. So actually the name itself conveys that it's a prototype. There is some virtual thing, by using that we can create the actual things. For example, if you are building a new house, then there is some prototype. Using the prototype, you can use the prototype design to create the actual object. So it falls under creational design pattern because it plays its role while creating the new objects. So create new objects by cloning or copying. This is the one statement that defines the meaning of this prototype design pattern. Suppose if your application needs n number of objects of the similar object means, then you can create the object for only one time, and you can clone or copy those objects for n number of times. By doing that, you can save time and also memory and also computation power. So these are the two real-time examples where prototype design pattern plays a major role. For example, suppose if a Java application is trying to read the data from database, example name and weight of a dog. So that the database will return the name and weight of the dog XYZ and 10 kg. Using this information, Java creates an object for dog. So that object is called dog object, name XYZ and weight 10 kg. If a Java application needs the same similar kind of data and it needs to create a similar kind of object, means there are two ways. One way is the Java asks the database once again, it will return the same data and Java application will try to create the same object. That's the one way. So suppose if you have 100 objects requirement, means then 100 times database call will go. That's very costly operation in terms of time and in terms of competition. So we can do in another way by using this actual object as a reference. We can copy this object to n number of times. Technically it's called cloning. So if you want to tell in layman terms, it's just copying. So using this dog object, we can create dog 1, dog 2, dog 3, n number of dogs by consuming less amount of memory and also less amount of resources. And the second example, if you are a user, if you are trying to download a movie from the internet, if suppose the movie name is Mr. Bean movie, what you will do is you will try to download from internet. So it may, if the size of the movie is 1 GB, means it may take nearly 30 minutes for downloading that. After 30 minutes, what you do, if you have watched that movie, means you will tell to your friends that the movie is very nice. So what your friends will do is, your friends will also ask you regarding that movie. So what you do is, you will try to copy the existing movie either to pen drive or DVD or disk, and you will try to give it to your friends. This is also a prototype design pattern. Here, you are trying to copy a source to a number of virtual things, so that you can save the memory. In this case, you can save the data and also time. So thanks once again. In the next video, we will try to explain the prototype design pattern using real-time examples using Java code. Now we are going to discuss about object pool design pattern in theoretical way using some real-time examples and using some Java-oriented implementations in a detailed manner. In the next video, we will discuss about object pool design pattern using some sample code. So we will try to implement the object design pattern using some real-time example scenario. So first, what is object pool? So actually pool is a collection of something. If we consider swimming pool, it's a collection of water where n number of people can swim at a particular time. Similarly, object pool is a collection of objects. So n number of clients can be served by that object pool at a particular moment. So first, object pool design pattern falls under creational design pattern. The reason behind that is this design patterns, it comes under the stage that during the object creation stage. That's the reason why it falls under creational design pattern. So this pattern falls only at the object creation time. And the second point is reuse the objects that are expensive to create. So this statement would be explained using this real-time example and the Java-oriented real-time example. So this is a real-life example. If you are studying if you are doing engineering, means then you would have to write exams for the 8th semester. So nearly 8 semesters. So for each semester there would be n number of papers. So for writing the exam, you would try to study a number of books for one particular paper. Some people would find it difficult to buy those books because the books are very expensive. At that time, what they would do is they will try to get the books from the library. So if I am that person, I will try to get the books that require books from the library. So after that semester, I will try to return those books to the library. So here I am trying to get the books from library. So library is serving us. After finishing our job, we will try to return those books to the library. Then library uses those books to serve other people. So here the books are the objects. The books are getting reused. So instead of buying the books, we are trying to get books from the library. After finishing our purpose, our job, we are trying to return those books so that the library representative will reuse those books and that library representative will serve many people. So that's the real life example where object pool design pattern is implemented. And the real time example where object pool design pattern is useful in Java. If there are n number of clients, now nearly 1000 clients. 1000 clients are trying to create a database connection pool. So if you create a one database connection pool itself, it's a very expensive object because it involves n number of resources. If suppose 1,000 clients are creating this similar kind of object means, then the expensive would be 1000x. So instead of that, what we'll try to do is we'll try to reuse the object that were already created by someone. That's the person is called reusable pool. This reusable pool, what it do is it will try to create some object, some limited object. It will try to manage the clients. For example, if suppose 4 clients are asking the objects means, this reusable pool size, this reusable pool will try to serve those 4 clients. This reusable object pool will act as a manager for the objects. So it will try to it will try to get the used objects from the clients, and it will try to give those objects to the clients who are aspirant to get those objects. That's the power of this reusable pool. So these are the advantages when we use this object pool design pattern in our code. The first advantage would be boost the performance. So since the object creation is a costly operation, in some cases, when we consider database connection pool, it's a very costly operation. Since we are reusing these objects, we are trying to improve the performance. So it will boost the performance automatically. And then it saves the memory. For example, if suppose n number of clients are using n number of objects, means that n number of objects would occupy some memory. Since we are using the object, that it would implicitly save some memory. And then it reuses the objects, it saves resources also. Because to create an object, it needs some n number of resources. Since we are reusing these objects, we are trying to save the resources for some other purposes. These are the advantages. There are other advantages are also applicable for this object pool design pattern. We will try to cover those things in the upcoming video when we try to implement the actual. When we try to implement the object pool design pattern using some real case scenario. So at that time you will see in depth about this object pool design pattern. For now, just get this idea theoretically. Please, we will try to implement these theoretical ideas in the practical way in the upcoming video. Thanks once again.